Okay, memoization. Odd word, brilliant concept. It's what programmers do when they realize their computer's memory is better than theirs. Ever told yourself you'll remember your shopping list only to stand in aisle 7 wondering why you're staring at tins of baked beans? Memoization is the opposite of that. It's writing stuff down so you never forget and never have to start from scratch again. Basically, memoization is a method where your computer stores results it's already figured out. Think of it as digital post-it notes scattered all over your computer's desktop. Reminders that say, "Oi, you've done this already, no need to waste time doing it again." This is perfect for Fibonacci numbers, those pesky figures that continuously pop up like unwelcome guests, each one relying on the two that came before. Without memoization, your computer recalculates each number from scratch every single time, like a goldfish doing laps in a bowl and constantly discovering the same plastic castle. Let me spell it out clearly. Memoization means no more endless recalculations and no more wasted processing power. It's the difference between running marathons blindfolded in circles and calmly strolling from point A to B. Here's why memoization is brilliant for the Fibonacci problem specifically. No more recursion nightmares. It avoids all the repetitive nonsense of recursion, no stack overflow crashes, and your computer won't explode in frustration. Instant access to results. Each number is calculated once, stored, and instantly available whenever you ask for it again. It's like Netflix, but for numbers. Everything you want, ready whenever you need it. Visible efficiency. You see clearly how each Fibonacci number is constructed from the ones before, providing crystal clear learning opportunities, preparation for bigger concepts. It's the gateway drug to dynamic programming. Once you master memoization, you're set for tackling bigger, more impressive coding puzzles. Memoization trades a bit of your computer's memory space for a massive saving in computing time. It's a deal your computer is begging you to take. Here's how it goes down in plain English. You start by writing down the first two Fibonacci numbers, 0 and 1, no surprises there. Then, instead of forgetting them, you store them in a list, a digital notebook of sorts. You use these stored numbers to easily calculate the next one and the next one, each step building on what you've remembered. Continue this systematic process until you've got all the numbers up to your target. Basically, your computer becomes a clever little archivist, carefully noting each calculation in a handy list instead of throwing it out immediately. Imagine you're cooking the perfect Fibonacci recipe and each ingredient is clearly labeled. You start with your simplest ingredients, 0 and 1. Put them on the shelf clearly labeled Fibonacci numbers. Now to cook up the third number, you add your first two ingredients, 0 plus 1, and pop that result, which is 1, on your shelf too. Continue cooking. To get your fourth number, add the second and third numbers, 1 plus 1 equals 2. Keep it on the shelf. Repeat this simple recipe until you reach your desired Fibonacci number. Every new number is neatly stored and ready to be used in later calculations. At the end, instead of chaos, you have a beautifully stocked pantry full of Fibonacci numbers neatly arranged and ready for immediate use. The beauty of this approach is its sheer efficiency. Let's contrast quickly. Without memoization, imagine repeatedly baking a cake from scratch every time you want a slice. Ridiculous, right? It takes ages and nobody enjoys it after the third cake. With memoization, you bake one massive cake once, cut it into slices, store them and grab a slice whenever you want. Instant access, zero repetition, maximum happiness. This method grows linearly, meaning doubling your target Fibonacci number just means double the work, not quadruple, not exponential, and certainly not enough to crash your computer. Memoization isn't just a cool party trick, it's practical, perfect when you need the entire Fibonacci sequence quickly available for analysis or display, or when you're teaching students and want them to clearly see the full pattern of Fibonacci numbers. And of course, when you have to repeatedly answer questions like, what's the 10th Fibonacci number? How about the 9th again and the 8th? Basically, any scenario where you're repeatedly referencing Fibonacci numbers is screaming out for memoization. It's efficient, clear, and, let's face it, pretty satisfying to use. The best bit for beginners is clarity. It teaches crucial ideas in computing. How storing intermediate results prevents redundant work. Why organized storage, like arrays or lists, is your best friend. The power of simplicity. Solving problems from the ground up clearly and methodically. Visualization, seeing the numbers laid out clearly, reinforces the concept. It's the computational equivalent of cleaning your room and realizing, oh look, everything's easier when I actually keep things organized. Memoization lets you easily show off the entire Fibonacci sequence, not just the last number. It's the coding equivalent of a victory lap, proudly parading your neatly computed results in front of anyone who doubted you or was slightly curious. This full display isn't just for bragging rights, it's incredibly useful for checking your work or debugging. Also, it's great for educating, showing exactly how the numbers evolve and, of course, analyzing patterns and relationships within the sequence. Iterative memoization isn't just about Fibonacci numbers. It teaches fundamental concepts that every good programmer should carry in their coding toolbox, recognizing patterns, spotting how problems can be broken down systematically, storing smartly, realizing the strategic trade-offs between memory and speed, thinking ahead, using past solutions to solve future problems more efficiently, dynamic programming basics, learning how breaking problems down and remembering past solutions solve seemingly daunting tasks. In short, memoization is an introduction to thinking smarter, not harder, a lesson every aspiring programmer and human being really can appreciate. Quick recap while you'll love iterative memoization. Faster than naive recursion, massively faster. Crystal clear for beginners, great for teaching and showing off. Offers the foundation for serious computing skills. In the next video, we'll reach peak Fibonacci efficiency, calculating these numbers with minimal memory usage. It's the ultimate minimalist approach, perfect for impressing programmers and boring your friends at parties. Stay tuned for Fibonacci minimalism, how to look smart while barely trying.